handling wastewater and poor sanitation, over-fertilization, too much N and P. And so this is our approach, our project objectives. As I said, we try to cover a holistic approach of the entire field. So this means it's not only the water treatment. RUS means recirculation fish pond, and we pass the water through a membrane bioreactor. And so in this field of membrane bioreactors, we're strongly involved in developing novel low fouling membranes. So we have good partners in Europe supporting us, and we are touching as well energy, so of course PV and biogas system, real-time monitoring for sure, even in Africa. You have access to everywhere, to mobile, to apps and so on. It's even more because there is almost no landline, trustable landline, so everything goes through mobile. And we want to develop something like a multi-purpose system which is not able to reuse and recycle the water. However, it can also digest, hopefully we have to demonstrate wastewater from fish farming, from fish industry, and from domestic wastewater as well. So the partners, just quickly, it's a mix of European partners and of African partners around this Lake Victoria, Kenya, Tanzania, and Uganda as well. And we are right in the middle. We just had midterm. And at the beginning, we had a bit more problems, but it was a bit difficult cultural-wise. But now we are on the right track. And we are just about to set up the pilot. The design is already done, and we are looking forward to start up with the pilot by middle of the year. So I'm coming to my end, and I'm looking forward to more discussion in the afternoon. And I would like to pass the floor to Mr. Kreuter, probably. Yes. Thank you very much for your attention.
Ladies and gentlemen, thank you for giving us the opportunity to be here in India and to intensify our cooperation. Professor Heunkes was talking about the past, his research project that he's doing in Africa, but we are also planning for the future having a research project between Europe and India. There's a call of H2020, which is a research program from Europe, and we will do a joint research on wastewater and groundwater and energy. I don't want to tell you more about that, so it's just that we are already in the process of implementing the idea. Hopefully we'll get funded by the European Union, and then we will be here for 3 years or even longer. To my background, I'm a geologist and a civil engineer, and I have founded in 1999 the first geothermal development company in Germany. I sold that company to an investor, and now I opened in 2005 my own new company with an English name, Geothermal Engineering. And I will tell you now my background, and then I will tell you why I'm here. It's not because of geothermal. That was the first idea, but I come to that later. So we are a consultancy and also a developer in geothermal energy. We are based in Karlsruhe. That's why we are here also. And we are operating on the international level. We are, I think, the smallest company here. We are just 10 people, but geothermal is a very specific market, which means all the other consultants, they might be big consultant groups with 10,000 engineers working, but their geothermal group is also only 12 people. So we're quite a good size in geothermal. And we want to transfer, and that's why we're here, we want to transfer our knowledge from geothermal into groundwater applications. And why does that make sense? I come to that later. First, our areas of activity in the center is project development. We select areas that are good for geothermal use, and then we pre-develop them with short money, and then we bring investors in, because the geothermal project that we are doing costs between 20 and 80 million euros. So they're quite big projects that we cannot fund ourselves. So we're working with investors, with funds, with pension funds that want to go into renewable energies, and geothermal is one of the renewable energies. As we are all geologists, geoscientists, we do exploration. We look where the water is, the hot water in the subsurface, and then we exploit it and make use of it, producing electricity, heat, coal. And we also do consulting, that is political consultants. We work for governments consulting them, we work for companies consulting them, banks, insurances. So that's our consulting part, but we are also strong in research and development. 30% of what we do is research and development. So we want to be just on the edge of geothermal development and bring new ideas into the market. I told you that I will tell you what we are dealing with when we talk of water. We're talking of geothermal brine. We have temperatures from 10 degrees up to 200, more than 200 degrees. 200 degrees looks like steam, but we are keeping the water under pressure so it doesn't go into steam. So we have to handle water of high temperatures. And we have very high content of dissolved elements, salt mainly. We have up to 240 grams per liter of salt and other elements in our water. So that means we have challenges. Challenges are corrosion, scaling, materials that have to stand high temperatures, and the contents of the geothermal brine have to be selected. We do hydraulic testing, and that under these circumstances, we have to test liquid of 150 degrees. We have to take samples in an environment of 150 degrees. What we have to do is we have to understand the reservoir. The reservoir can be porous, can be fractured, can be fault-related. So if we understand the reservoir, we can manage it, because geothermal has to be done sustainably. The oldest geothermal power plant now is 54 years old. So the systems can run for a long time, which means they're very economic if you look at a time span like that. The others, they are burning coal, they are burning oil, we are burning money. In the beginning, when we drill wells, we use a lot of money, but the operational costs are low, and if a power plant is up and running for 50 years and more, you can make a lot of money with it. So what is also typical for us is high flow rates. We are looking at flow rates of 100 liters per second coming from a well and being re-injected. That is also a challenge. And all these experience we can bring into the groundwater, and I will just give you one example of our research and development that can be easily used in your environment. We have built a device to take samples, and automatically several samples. Usually you go out every week, take a sample, go to the lab. Next week you go out again. And this device takes 12 samples. There's a refrigerator in it, you have you're attached to a grid, or you have solar cells and a battery. It's remotely controlled. You have online measurement of pH and others. So if you decide to change the sampling mode, you can do it remotely if the pH tells you that something has changed. So I think that's a very good, that has been a very good idea, because in conferences we found that people like that device very much, and we start, patent is pending, and we start selling it in May of this year. We did the same thing for gases, so we can sample also gases that can be used in volcanic regions in geothermal, because we are looking at helium and other gases that we need to look at if we want to do geothermal development, or if we want volcano not to erupt, or knowing when to erupt. What we are doing here in the project is we look at water management, groundwater management. We look at water harvesting. You can store the rainwater on the surface, but you can also use the reservoir, the ground reservoir, to store the water. And because the rainfalls are very intense, you have to get a lot of water inside in a very short time. And we can do all that. And we use technologies that are also from Baden-Württemberg. Helmknecht is a world leader in tunneling machines, but he's also doing drilling rigs, and this is a special drilling rig, a slanted drilling rig, and you can drill horizontally and do like a drainage in the subsurface to get as much water in it as you need to get away, to get rid of the monsoon rainfalls and bring them in the subsurface. We're a worldwide company. I've seen that SMS has an office in Uganda. As a matter of fact, in 3 weeks I'm going to be in Uganda, and we'll see what we can do for the country in electricity production from hot springs. And that's our office in Karlsruhe, and I'm happy to discuss with you everything that is related to groundwater. Thank you very much.
Professor Mario Schmidt from the University of Applied Science, Pforzheim, and he will conclude our session this morning.
So it's a little bit late, I'm sorry for that, but I hope you give me some more minutes to present you some more common thoughts of mine now. And my name is Mario Schmidt, and it's an honor for me to be here. And I come also from one of these universities of applied sciences. My colleague just mentioned it's the University of Applied Sciences in Pforzheim. It's between Karlsruhe and Stuttgart. It's a rather small city with 120,000 inhabitants. We have 6,000 students, and so on. So I'm the director of the Institute for Industrial Ecology. That's a research institute, and our expertise lies in different fields concerning environmental questions, sustainable development, for example. And here you can see some activities at our institute which are done by my team, and especially I'm responsible for all these things, especially student programs about resource efficiency management, about life cycle or sustainability. We have a PhD program, for example, about energy systems and resource efficiency, and we have several research projects at our institute. So the key competence or our profile is mainly to analyze product and production structures. So we don't develop any technology, but we analyze production systems and how we can improve the efficiency in these systems. So if we talk about, for example, smart cities, what does it mean? I mean, smart cities means that we have to improve, that we have to develop the infrastructure, for example, to fulfill the needs of modern society, of the population of the cities. And in this context, we always talk about smart supply. Yeah? That's a very important point. And I've learned that you here in India have a major challenge in the development of these infrastructures, for example, for water, for energy, for waste management, for public transport, for example. And this is very interesting because the growth of this demand is accelerating, yeah, due to the increase of wealth, of course, of population, of migration to the cities. And my personal opinion, but we can discuss about that, is that the race to catch up the rising demand becomes more and more difficult. So my question to you is, does anybody think about about a demand side management? That means about a smart demand, not only about a smart supply, but also about a smart demand. And what do I mean with that? Sure, everybody of us, we want to get more welfare, we want to get more consumption, we need more production and so on. But the problem is that the increase of these things means that we have to increase also the supply. That's clear. So my suggestion would be increase our efficiency in water usage, in electricity demand, in waste production, for example, because with every kilogram less waste and less water demand and less kilowatt hour, we relieve the infrastructure problem. So that's a very important point, and this is also our approach at our institute. So we look into the companies, we look into the production systems, and we want to save energy, to save materials, to save water, wastewater, and so on. So we analyze these energy and material flows in the companies. We use for that different methods. For example, the material flow cost accounting, which is a method which is also standardized by ISO standard, for example, 1451. It's an international standard, and which is very interesting because we see here both sides, not only the environmental side, but also the economical side. So our results from several projects we had done, for example, here is savings of water demand about 90% in companies, savings of energy 20%, and therefore also savings of cost for the companies about 30%, and that means also increasing profit up to sometimes of 100%. So we just finished a very interesting project concerning these things about resource efficiency. We have now 100 best practice cases in Germany, and I can announce that these practice cases will be published also in English language in the summer, so perhaps it might be interesting for you. Here you can see some of these projects. So we have many innovative measures in these companies from different branches, different sectors, and I think this would be quite interesting. We also offered for these companies free software tools to analyze their production systems. This is a campaign sponsored by our state government, so the tool is free for the companies, and they can do material flow analysis, for example, as well as material flow cost analysis, cost calculations, and carbon or water footprints. Here, just a small example is from Mr. Juncker. Yes, here, Mr. Juncker, his company, we analyzed his production system. And here you can see an example. This is a Staker diagram, a flow chart of his production, or part of his production, and you see the mass flows in this slide. So 40 kilograms goes into the product. But what is more interesting is the losses, or other losses, which you can see 12 kilograms. And what is more interesting is this slide, and this is not about kilograms or kilowatt hours, but about cost. So you can see the euros or the dollars $300 goes into the product, but more interesting, 164 euros in this case goes into the losses. And that means not the waste management for that, but also the added value which you lose by labor, by invest, and so on. And so this picture shows you why it is so important to think about the losses in your companies, because it's good for the environment, but also for the company, for business, if you can save these potentials. So that I want to show to you, and if you're interested to learn more about our approaches, about these methods, you can ask me, and I thank you very much. And let's avoid that by a smart demand side management of the production, increase our efficiency at the demand side. Thank you very much.
This brings us to an end of the enriching first half of today's meet. Thank you so much, all the delegates, for presenting your companies, including the industry and the academia from Baden-Württemberg. I got it right. Yes. Thank you. I guess we are all a little hungry now, so we'll take a lunch break for about 45 minutes. We are running a little late on the schedule, so if we can curtail it to 30 minutes, it will help us. The lunch is served across the elevators on the same level. But before we head out for lunch, I have a small announcement to make. Post-lunch, we'll be running certain parallel, multiple sessions after that. And a special feature of this conference was that we get a chance to meet one-on-one with all the delegates here. So it could be a B2B or a B2C meeting, one-on-one post-lunch. And that is arranged in a roundtable format in the Udiam Conference Hall. Again, it's across the elevators on the same level. And the second track will host discussions with Karlsruhe International and Economic Development Group of VIA, and academic discussions with Lord Mayor and Professor Hoinke. This will be held in the VIA boardroom, which is the adjoining room to this hall. So these are the two sessions that we will have post-lunch immediately. So once again, thank you so much for your presentations, and I invite each one of you to please join us for lunch across the elevators on the same level. Thank you. Yes.